Are you hear my voice
Yes, sir.
clearly? Hello. Yeah. Uh, Yesterday, I think we have
Yes, sir.
discussed. Yeah. Yesterday we discussed about D MOSFET. Are you looking at the screen?
Yes, sir.
Yeah. Last class, I think we have gone through the D MOSFET to some already. The D MOSFET consisting of so the DMOS consisting of a P substrate for a N channel. Based on that, the two N regions are formed by adding a pentavalent impurities here, and again an N channel, another N channel is placed here. On this, silicon dioxide is insulated, and above that silicon dioxide, we are again placing aluminum metal contacts here. And from this aluminum metal contacts, we are taking out three leads. The three leads will act as one is the drain, gate, and source. Right? Based on that, how the channel is depleted. Here we can see how the channel is depleted in the channel. So the depleted channel generally for negative bias, negative gate to source bias. So for this negative gate to source bias we applied, the channel is depleted into the channel width. So the channel width is decreases, and the decreased channel width will control the flow of particles in the channel. So this is about the yesterday what we discussed in the D channel. Based on that characteristic curve, drain characteristic curve and transfer characteristic curve we had drawn, right? Next, coming to the E MOSFET. Next one is the enhancer MOSFET. Next is the E MOSFET. So in the E MOSFET also, we are doing the same thing here. In the E MOSFET also, we are doing the same. Same thing, the P substrate is taken here. On this P substrate, two N regions are doped, two heavily doped N regions are placed, that is N plus regions are placed here on either side of the, on both sides of the, or two ends of the P substrate. After doping here, we are using aluminum metal contacts. The aluminum metal contacts is connected or inserted into the two N plus regions, inserted into the two N plus regions, and these two regions, two aluminum rods take it out. The two aluminum rods, one is acting as a source, another one is acting as a gate. Sorry, drain. One is acting as a source, another one is acting as a drain. Right? In between the source and drain terminals, again an aluminum metal contact is placed in between, and this will lead is taken out, and this will act as a gate. Right? And this gate and this is the channel. This is the channel region. This is the channel region. This channel region doesn't have any material in the E MOSFET, enhanced MOSFET. Why? Because in the, if you go for a uh, D MOSFET, the N region is placed here. See here, observe here. This is the N region. The N-type metal, semiconductor material is placed here. But whereas when you come to this one, there is no question of any N region is placed. This is simply an P substrate only. No question of any other material is placed here in between the source and drain. In between the source and drain, right? It is left free. Then, when you go for, are you hearing my voice? Hello?
Yes, sir.
Yes, sir.
Because my microphone is saying that power is off, like that. That's why I'm asking. Right. So now I will have to bias this circuit. So how to bias the circuit means, again I have to take the uh, I have to take this EMOS, and this EMOS, what is the condition now? The gate to source voltage is applied by a positive voltage. Here, there is a thing you have to observe. The gate to source is a positive, and the source to drain is a drain terminal is always positive. This is called as VDS, and this is called as VGS. Now the VGS is a positive voltage here in this one. VGS is a positive voltage, right? So when VGS is positive voltage, we said that the gate is isolated from this P substrate by a silicon dioxide material, and this will act as a dielectric material in between this channel and this is a channel here. Now in this one, when gate is positive terminal, positively connected, what happened? The purpose of gate is it is attracting the charge carriers, right? It is attracting the negative charge carrier because gate is a positive. So it attracts the negative charge carriers from the P substrate. P substrate నుంచి negative charge carriers attract చేస్తుంది. P substrate majority carriers ఏమి holes are the majority carriers, right? Whereas the electrons are minority carriers. So these minority carriers are moved towards the gate. So there existing a more amount of negative charge carriers are deposited here. More amount of negative charge carriers are deposited here because it is attracting. It is attracting, and this forms a channel. This forms a channel, right? So as the gate is a positive voltage, then the gate attracts the negative charge carriers in the P substrate, and the carriers which are existing nearby this region, the negative charge carriers are moved towards the surface of this one, right? And this forms a channel. Now this is a channel now. Now this is a channel, right? This channel will act as a bridge between the source and drain. The channel is acting as a bridge between the source and drain. So the particles which are reflected from the source, because source is negatively connected, right? Negative terminal is connected. So when source is negatively connected, the charge carriers are majority charge carriers are electrons here. Electrons are the majority charge carriers which are repelled from the source terminal and are excited and move towards this channel. They enter into this channel and they mixed with these electrons, and these particles are moving in this direction. Right? And the particles are again here. This is a positively drain is a positive terminal. So the electrons are attracted towards the positive terminal, and the electrons are moving in this direction. Electrons are moving in this direction. So they exhibit a drain current of ID. It exhibits a drain current of ID. Right? When VGS is equal to 0 means no channel is formed here, no current is there. But when VGS is equal to positive voltage only, this enhancing process. Enhancing means channel, actually there is no channel here. When VGS is positive voltage, then the channel is enhanced. The electrons are enhanced here. Right? So this enhanced path, this enhanced electrons will arrange a path or a bridge between the source and drain. So the current is flowing. So this constitutes a current. So this is a simple operation of a E-Mosfet, enhanced Mosfet, right? Now, what are the characteristics now? We will go through the characteristics now. Drain characteristics. So these drain characteristics are drawn. These drain characteristics are drawn between I think it's already well known, right? You know very well what is the drain characteristics you can draw between the VDS and ID. VDS and ID. So when there is no VGS, positive voltage is there. So VGS is equal to 0 is there, and 0 when 0 is connected. So there existing a drain, right? And above that, this is VGS equal to 0 volts. That's 1 volt, right? Plus 2 volts. This is VGS is equal to constant, right? So the maximum current here is as VGS goes on increasing, the IDSS goes on increases. Is it not? Right? So if you take the transfer characteristics of this one, this is the drain characteristics, and here it is the drain characteristics. The regions are common. I think when we see that J effect will has a 3 regions up to this point, even this is called as a ohmic region, and this is called as pinch off region. So after this, this is called as breakdown region. This is common, right? This is called as breakdown region. Okay, so the definition for pinch off is again same here. At what voltage of VDS, right, the current will starts constant, or the current will have maximum. Then that point, the voltage point is called as a pinch off. The pinch off also occurs here. Right. Next, coming to the transfer characteristics. So there is no question of any voltage here, but a small amount of voltage is existing here. This is the transfer characteristics. This is VGS. So VGS is equal to negative voltage. We are not getting anything here. So only VGS is positive. As VGS is equal to 1 volt, this will be the point. As VGS is equal to 2 volts, this will be the point. As VGS is 3 volts, this will be the point. So like this, this transfer characteristics are goes like this, right? This is called transfer characteristics. So the transfer characteristics, from the transfer characteristics, you can find out the GM, transconductance. From the drain characteristics, you can find out the RD, small RD, right? Drain resistance, small resistance, right? And the symbol for this one is in the symbol. And the symbol for EMAS. Is similar, but there is no solid line here, right? This is the gate terminal, and here for the D Mosfet we draw a solid line here, but instead of solid, you have to put a dotted line, right? And from this dotted line, you can put a solid line here, and this will be the drain terminal, right? And from this is the source. And in between this source and drain, there is existing a line called as substrate line, right? Substrate. This is called as N channel. N channel effect, right? EMOSFET. Similarly, for P channel, the same thing you can draw here. Source, drain, and substrate. And substrate arrow mark you have to show like this. Showing this arrow mark with the P channel. Okay. So this is the construction symbol, and this is the transfer characteristics, and this is our construction, and this is operation of a FET. Are you clear about this operation? Right? So here in EMOS, the gate to source you have to connect a positive voltage, not the negative voltage. EMOS doesn't work for negative voltage. It works only for a positive voltage. Right? And VDS is common. Drain is always positive terminal and gate source is always negative. But JFET also, we are connecting the drain to source voltage. Drain is the positive terminal is connected, and gate is the source is the negative terminal is connected. This is common for all the FETs, but only the gate. JFET will have only completely reverse bias, and DMOS will operate gate. VGS is negative voltage as well as VGS is positive voltage. But EMOS, enhanced MOSFET, will work only for positive voltage, right? So this is about the junction field effect, EMOSFET, enhanced MOSFET. Similarly, if you go for designing a P-channel MOSFET, P-channel EMOS, you just make instead of this, you have to connect the So when VGS is equal to 0, if VGS is applied between the drain and the source, then in the absence of channel, there are no charge carriers moving from source to drain. Right? So 0 current is flowing when VGS is equal to 0. Similarly, as the negative voltage is applied, right? So at that time also no current flows. So only gate to source is positive voltage it was. Only gate to source positive voltage it was. Right? So coming to this characteristic curve, here we have to take not this is the 0 voltage, here is a 0. Only a small, this is the 0 voltage. VGS is equal to 0. That's 0.5. Right? So that's why the characteristic curve looks like this. This is the transfer characteristic. Right? These are the two things you had observed in the DMOS and EMOS. Right? Any doubts you can raise. Any doubts? If you have any doubts, you can raise. I'll hear my voice. If you have any doubts, you can raise. No problem. So in unit 5, we covered introduction to MOSFET, oxide semiconductor over, types of MOSFETs over, characteristics of depletion MOSFET and enhanced MOSFET is covered. Right? So in the 4th unit, we left only JFET biasing. Right? We have to cover the JFET biasing. The JFET biasing is covered. I think, are you okay up to this? Are you hear my voice or not?
Yes, sir.
Right? If it is okay means then I think there is a biasing part is there. The biasing part we'll cover later on. The next Wednesday, Thursday we'll cover this biasing part. Up to this, if you have any doubts, you can raise. Right? Otherwise, I'll just go through once again the recap of all the things. Right? And the current equation also we have seen, right? This current equation is applicable for all the things, all the uh, current equation, FET current equation. So for FET current equation, what is the given? We have ID is equal to ID or IDS is equal to IDSS into 1 minus VGS by VP whole square. Right? This VGS by VP is a mod. Mod is that. The mod indicates irrespective of plus and minus, you have to take the plus only for VP pinch of voltage. Don't take the negative voltage. Okay. This equation is applicable for all the gate FETs, not only JFET. You can apply for JFET, JFET, and DMOS, DMOS FET, and EMOS FET. Because if you go for a JFET, the VGS will become negative, right? VGS will become negative voltage. For DMOS, you can go for negative voltage as well as positive voltage. And the voltage apply, right? Based on that, the current will changes. ID drain current goes on changes, right? And EMOS also we have only the positive voltage. So మనకి యాక్చువల్గా DMOS లోనే JFET ఉంది ప్లస్ EMOS రెండు ఉన్నాయి, రెండు వర్క్ అవుతుంది, రైట్? అది దట్ ఈస్ ద డిప్లేటెడ్ MOSFET. కానీ EMOS లో మాత్రం ఓన్లీ VGS will become పాజిటివ్ voltage. అది గుర్తుపెట్టుకోండి, రైట్? That's all for this EMOS. So Wednesday, just we'll go to what is the biasing techniques, right? What are the different biasing techniques? I think what are the different biasing techniques? Can anyone tell? What is the biasing techniques? Can anybody tell? Anybody answer?
Fixed bias. Fixed bias, self bias.
Fixed bias, right? Somebody is watching TV, yeah? Voltage divider. Voltage divider bias or self bias. This is one. It is called feedback. Drain to source, drain to gate, gate resistance. These are three bias. So the biasing is same here for what we studied in BJT. The purpose of bias is to stabilize the operating point. Then to stabilize the operating point. What is meant by operating point? What is meant by operating point? Operating point is the point considered on the output characteristics. Consider only output characteristics. So this is the output characteristics. Here, the output characteristics are drain characteristics. Here, the output characteristics are drain characteristics. When it is 0 volts, minus 1 volt to minus 2 volts, and this is plus 1 volt. Whether it is a JFET means only this will not appear, right? If it is a DMOS means these three characteristics are appears. Is it not? If it is a EMOS means these three will not appear, only this voltage, this one is appears. Right? Whatever it may be, this is the IDSS. Next one, trying to source equation, correct. So here, this is VDS. Here, same, we had to draw a concept called as a load line concept. The concept called as a load line. I think this already I explained in the classroom. DC load line. So in this load line, we have to keep this operating point exactly at the center. Is it not? Q. The Q point is nothing but the minimum values of IC and VCE. Minimum values of IC and VCE. Or minimum values of zero signal collector current and VCE. Adi akkada. Ikkada kuda same minimum values of VDS and ID. Minimum values of VDS and ID, right, is called as the operating point on this load line. So here same thing, we have to keep this operating, because the operating point may also change in the FET also. Enduku FET lo two gate junctions are reverse bias. Kada FET lo two gate junctions are reverse bias. Ila తీసుకున్నాం. FET lo idoka reverse bias junction, idoka reverse bias junction, right? The P here is in channel, right? So this deflation is forming here, right? And a narrow gap is here. This is called as a pinch off region. Pinch off region. What voltage is existing at this point between the drain and source? These are the gates. Is it not? So there is a thermal runaway there, because the flow of particle will generate temperature here, right? This rise in temperature will change the characteristics of a two gate junctions. So which internally there is no thermal runaway existing here. Be careful. Not just like in a BJT, there is a thermal runaway is existing, self-destruction is there. But there is no question of self-destruction here, because it is field control. The field is fixed here. Heavy intensity, the field is generated here. This will totally control. There is no question of any thermal runaway existing here. But even though there is a temperature increase, so that the variation of VDS voltage and ID will change because of VGS. The VGS voltage change the operating point may shift up and down. So we have to keep this operating point stable. So to keep this stable, again we have to go for a stabilization technique. So already we discussed about what is my stabilization technique, what is my compensation technique. The same stabilization technique will consisting of application of a bias. So this applied bias will always maintain the collector current, minimum zero signal collector current, minimum zero signal collector current IC. Ikkada kuda minimum drain current is maintained. Minimum drain current is maintained, and minimum drain to source current voltage is maintained. That is a condition for operating point. So to maintain minimum, this means we require a bias. So the same three types of biasing techniques we are using here also. A fixed bias technique is applied, and voltage divided bias technique is applied, and feedback. So this drain to gate resistance feedback method is applicable only for EMOS. So it is not applicable for JFET and DMOS, right? It is only applicable for EMOS. We cannot apply this for remaining biases, because the remaining biases, the gate junction is reverse bias. The remaining transistors, if you take a JFET, ఈ JFET లో కానీ D MOSFET లో కానీ ఈ రెండింటిలో gate junction always we are making the reverse bias. But E MOSFET no, we are not making this gate junction reverse bias. Gate is a power bias. Gate we are applying a positive voltage. So that's why we can apply this drive to gate resistance method in the E MOS. But here no gate is a reverse bias, no current is flowing in the gate. So there is no question of any input current. కాబట్టి you cannot apply this drain to gate resistance. So the other two methods you can apply for these two, JFET and right. So fixed bias means what we are doing? We are tapping a heavy value of resistance is placed between the VCC to base. Transistor a heavy resistance of RB is placed between VCC to base. Heavy resistance of gate resistance placed from gate to the ground, right? Gate to the PD, negative voltage. So that voltage that creates a gate voltage of VGG, right? So that means we will go to each and every class on Thursday. Are you clear? So not going very in depth in this one again because we have to go to each and every later on Thursday. So a fixed bias and voltage divided bias is applicable for all the JFETs and DFETs, DMOSFETs, and an extra of drain to gate resistance method is applicable only for EMOS, enhanced MOSFET, right? So how the biasing is applied and how it happens, that we'll see on Thursday class, right? Up to now, if you have any doubts, you can raise. Because it is online class, you cannot express things, right? Maybe my writing and this diagrams will leads to some confusion. So that's why you can ask any doubts. Yes. Any reply? Any answer? My voice is audible or not? No doubts, huh? Hello?
Yes, sir.
Don't have any doubts, right? Okay, right. Thank you, right? And we'll see you on Thursday with the FET biasings, right?
Okay, sir.
Okay, sir.
And afternoon 2 o'clock, I think I am not taking any class. Okay, na? Every day, morning times only I will take because you are having a lab on Thursday afternoon also. Only morning class only I will take, right? Only morning classes I will take. I don't take any afternoon classes. If any afternoon classes is there, I think only this day. Tuesday only I am having 2 o'clock, I think so, 2:50 I think so. That's why I'm taking in the laboratory class. Laboratory class తీసుకుంటున్నాను. Right? If you have any doubts in the laboratory, record work, you can also ask now. Because be careful, you complete your laboratory records in all respects, right? Graphs కానీ అన్ని కానీ all respects complete చేసి when you are coming back, you submit on first day itself. Because I need to correct the records because immediately after this month, third we are having offline internal examination, right? Offline internal examinations ఉంటాయి మీకు కాబట్టి మీరు నేరుగా రెడీ చేసి పెట్టుకోండి ఇప్పుడే because today tomorrow Wednesday Thursday also you are having lab slot. ఈ ల్యాబ్ స్లాట్ ఎవరైనా తీసుకుంటున్నారా? Need to answer CR only.
Sir, నిర్మలా మేడం తీసుకుంటా అన్నారు సార్.
అది థియరీ క్లాస్ తీసుకుంటారా?
ల్యాబ్ క్లాస్ తీసుకుంటా అని అన్నారు సార్.
అదే ల్యాబ్ క్లాస్ థియరీ క్లాస్ తీసుకుంటారా, లేకపోతే ల్యాబ్ క్లాస్లో ల్యాబ్ గురించి చెప్తారా?
థియరీ క్లాసెస్ సార్.
ఓకే. ఇంకా ఒక బ్యాచ్ అంటే ఈరోజు మరి ఉంది కదా, ఈరోజు థియరీ క్లాస్ ఉంది కదా, థర్స్డే తీసుకుంటాం అనుకుంటారా మేడం?
థర్స్డే తీసుకుంటా అన్నారు సార్.
ఓకే, థర్స్డే తీసుకుంటాం. సరే సరే. Okay, right. So anyhow, you just complete your records in all formats, all respects, and be ready with your recorder. Right. On Thursday morning, I will complete Thursday and Friday. Most probably Friday, Thursday, Friday, and Saturday. These 3 classes, I will go through the biasing techniques of a FET. Right. After that, we need only 2 classes enough to complete the rest of the syllabus. Okay. Most probably by Monday, Tuesday, I will complete the syllabus. Okay. Right. Shall I stop? And I will send these notes, scanned copy notes, by through WhatsApp. Okay. Okay. Right. Okay. Right. Thank you. Have a nice day.
Thank you, sir.